So thank you for being here today. The goal of this webinar is to give you an overall idea on what are the key areas you should consider when implementing a strategy to minimize the energy consumption. Of course, this topic is a huge one, and we don't expect to cover it fully. In the coming months, we will be running more webinars on more targeted subjects, energy efficiency in the kitchen, for instance. But let's talk about the subject of today. The Carbon Trust estimates that you could cut your hotel's energy bills by as much as 20% just by implementing simple and inexpensive eco-measures. If you want to make your hotel property greener, well, this is a good place to start. Hence why we chose that topic as one of the first ones. Lighting control, optimizing the room and the water temperatures, raising energy awareness among the staff are just some of the options. Equally importantly, energy efficiency measures are not only going to prove economically beneficial, but are also likely to benefit the reputation of your hotel. So in this webinar today, a peer of yours, a hotel owner, and a champion of sustainability will share with you the most important best practices with practical examples and solutions. I would like to start also by thanking our partners for this webinar, the Pacific Asia Travel Association, PATA, and the GSTC, the Global Sustainable Tourism Council, without which we would not be able to do this webinar today. So thank you for supporting us. Just another few words about the webinars. In general, they aim at bringing practical solutions for hotel owners who wish to green their operations. We aim at sharing best practices and creating a community of like-minded professionals. Look at your own property. I'm sure you came up with some practical solutions that are worth sharing. So if you wish to contribute to the future webinars or be interviewed in our podcasts, well, get in touch. Okay, just a few words of housekeeping, a few practical details. You won't be able to speak during these webinars, but feel free to ask questions to our speaker, and we'll try to answer most of them in the second part of the webinar. Also, the webinar is recorded, and you will receive a link to it, along with the slides and the contact of our speaker. If you cannot hear us, check your audio settings as indicated on the screen. And on the top right side, as seen on the screen now, you can ask questions. Feel free to ask all the questions you want at any time. Okay, let me introduce myself. My name is Alexandre Tsuk. I'm the founder of BookGreneer. And since we're organizing these webinars, allow me 2 minutes of self-promotion. BookGreener's goal is to offer enlightening travel experiences. We believe that hotels that care about the environment, care about their staff, are also likely to take better care of their guests. That's why we focus on promoting the most sustainable hotels in the world, hotels that are part of the solution, not part of the problem. And the way it works is very simple. Hotels fill a questionnaire on our website, and based on their green practices, we rank them and display them on our website. So I invite all the hotel owners who are listening to this webinar to list their property on BookGreneer. And once a hotel completes a self-assessment, an expert reviews it, and then we send a label that the hotel can display on their website. So any hotel that is committed to being part of the solution can be recognized as such. And the best part, when travelers want to complete their bookings, we direct them to the hotel's website. Yeah, that's right. No commission, no charge. We are truly fair trade. Oh, we ran a little promotion during this webinar tonight, just for you, dear audience. Any hotel that is listed thanks to you in the next month will be promoted. And the first 4 hotels will be promoted on our homepage for a week. And all the hotels will be featured in a blog post, giving them extra visibility. So, you know what to do. Join BookGreneer. A few words about BookGreneer Connect. This is our peer-to-peer skill-sharing platform. This is aimed at professionals involved in promoting sustainability in the tourism industry. Hotel owners, sustainability officers, labels, experts. The tool is free and allows any member to post a best practice, comment, add a tip. So I invite you to check it out, and there you can also view our first webinar on water conservation and the part 1 of this webinar on energy conservation. Also, we have now a podcast that we are showing, so please, I invite you to check it out. And it's BookGreneR/connect. That's easy. Okay, let me tell you a little bit what all this energy efficiency webinar series are about. In the first part that we will put up very soon on BookGreneR Connect, Patricio gave us a broad picture and told us what are the key domains to consider when thinking about energy efficiency.
Let me introduce you Patricio Gonzalez Morel, the keynote speaker and expert who's going to be with us tonight for about an hour. Patricio is a mechanical and environmental engineer with a broad experience in resources conservation and pollution prevention. Over the past 20 years, he has conducted detailed sustainability assessments in more than 120 hotels all over the world. Through his work, he has been able to demonstrate that low-cost and high-return equipment and operational upgrades can generally reduce a property's energy and water costs by between 15 and 25%, while significantly enhancing its environmental performance. He's also worked with large tour operators like TUI, First Choice, Thomson, Thomas Cook to lower the environmental impact and operating costs of their flagship hotels. He led the technical activities of major international sustainable tourism initiatives in Jamaica, Egypt, and the Caribbean. He's now a partner in Athena Cleantech, a Singapore-based consulting firm specialized in energy efficiency and sustainability. So if you want to get in touch, I recommend you do so through his LinkedIn profile. Welcome, Patricio.
So good morning to everybody, wherever you may be. So the topic of this presentation is energy efficiency in hotels. It's a very big topic, and I don't have that much time. So what I'm going to do is just focus on a couple of issues related to energy use in hotels, and mainly lighting and air conditioning. Then towards the end I'll touch upon hot water use, but that's going to be it. There are many more topics, and maybe what we can do is just save those for another webinar. So let me see. Okay, let me begin by I think that maybe part of the screen is covered by this little control panel that I can't seem to remove. In any case, I think we can just go ahead like this. So when it comes to energy use, many hotels don't really use this resource very efficiently in their buildings and operations. And therefore, most hotels have really an excellent opportunity to save a lot of money by putting in place energy efficiency measures. Based on my experience, and I've been doing this work for about 20 years, and I've worked all over the world with hotels, big, small, high-end, middle-end, low-end. Most hotels really can save about 20% or more in energy by putting in place energy conservation measures, which are not very complicated, energy conservation measures which are not very costly, and which on top of that are incredibly cost effective. In most cases, I'm talking about energy conservation measures that yield a payback of anywhere between 1 to 2 years, and therefore these really are excellent resources, really excellent investments. I'll give you an example here. This is an example from a hotel where I worked in about 6 years ago, and it's a small hotel. I think they have between 20 to 30 rooms located in Central America. It's called Arbol de Fuego, and we conducted an energy efficiency diagnostic in this hotel, and within a span of a year or maybe a year and a half after the end of the diagnostic, this hotel had actually achieved some pretty impressive results. They had reduced their electricity consumption by 39%. They had also reduced their maximum demand by 42%. This is important for many of the hotels around the world, which get charged not only for the kilowatt hours that they consume, but also for their demand measured in kilowatts that they consume. And And thanks to these two, thanks to the energy savings and the reduction in maximum demand, combined with also a switch to a more appropriate electricity rate, this hotel had actually managed to reduce its electricity cost by 59%, which resulted in financial savings of $370 US per room per year, which really is a lot of money. And what I would like to point out to you is that in the case of this hotel, we looked only at electricity because this was their main source of energy. However, probably the savings could be much greater if we had done a more comprehensive study at this hotel, looking also at thermal energy and looking at water conservation issues, etc. Okay, moving on to the next slide. For some strange reason, it's giving me a very hard time switching from one slide to the next. Okay, maybe we solved the problem. Lighting. So as I said, we'll start looking at lighting. And the first and most basic recommendation is to avoid using incandescent and halogen lamps. This is very old technology. The incandescent lamp was designed more than 100 years ago. It hasn't changed that much. And it's really quite a wasteful technology. The energy-efficient alternatives include fluorescent tubes, compact fluorescent lamps, which are also called CFLs, and also the newest additions to energy-efficient lighting, and these are LED lamps. These energy-efficient lamps, they last a lot longer than the older technology, than the incandescent and halogen lamps. And not only that, they can also reduce energy consumption by more than 75%. So they really are a very, very, very good option to put in place. Not only are they good technically, but they are also very good financially. Energy-efficient lighting is really a no-brainer when it comes to financial choice. So I will just give you an example. In this example, we're replacing a 50-watt halogen lamp, which is a typical small, very bright halogen lamps which are used in many hotels and restaurants around the world. So we're replacing this 50-watt halogen lamp with a 7-watt LED. The LED costs $30, which is actually quite a bit of money. However, when you look at how much money this change of technology achieves, it gives you savings of $130 US over the 25,000 hour service life of the LED lamp. And therefore, you're getting your investment back about 4.5 times, which is an excellent return. 25,000 hours, by the way, is equivalent to leaving one lamp on constantly for 3 years straight. So this is just to give you an idea of, how soon you'll be able to recover your investment. Obviously, if you only have that lamp on for 12 hours a day, the lamp will last for about 6 years. And one last point that I would like to make is that in all of these examples, I'm using the average energy cost of a kilowatt hour in the US, which is 12 cents of a US dollar per kilowatt hour, which is actually fairly inexpensive. In most of the countries around the world, electricity is actually quite a bit more expensive. For example, I live in Singapore, and there the energy costs about 50% more than it does in the US. So whenever I give you a figure such as, in this example, a savings of $130, in my case in Singapore, this same measure would have achieved a saving of almost $200 US over the lifetime of the lamp. Okay, moving on to the next slide. I would like to make a few recommendations with respect to the use or purchase of energy efficient lamp. The first recommendation is make sure you buy quality. There are many LED lamps, especially LED lamps manufacturers out there. Some of them are very well known, some of them are complete unknowns. And the problem with the unknowns is that they sell their product at a very low price, and it makes the product look very, very attractive. But unfortunately, a lot of these lamps are not good quality, and therefore instead of lasting 25,000 or 50,000 hours, many of them last maybe 5,000, 10,000 hours, and then they die, and therefore you never really are able to recover your investment, even if you did buy the LED lamp at a low price. Another thing to keep in mind when you're dealing with CFLs and with LEDs is you have to be careful with the light color. This is not a problem that you have when you buy incandescent or halogen lamps, because they always produce what is called a warm white light, which is this kind of yellowish light that we are all very familiar with. When you buy CFLs, you can actually buy them in 3 different light colors. One of them is warm white, which, as I just mentioned, is very similar to the color of the light that is produced by a traditional incandescent lamp. On the other end of the spectrum, you have what is called daylight, which is a very harsh white light, which in some cases is almost even bluish. And then between the two, you have cool white, which is neither yellow nor blue. It's somewhere in the middle. Normally, in most hotels, in public areas and in guest rooms, hotels install warm white lamps that produce a warm white light. The cool white is generally reserved for guest bathrooms, and the cool white and the daylight is generally used in work areas such as kitchens, laundries, back of house areas, offices, etc. So it's something that you have to be a little bit careful with. I've been to many hotels where within a single bedroom you have some lights are warm white, some lights are cool white, some lights are daylight, and it just makes for a very, very strange and unpleasant mix. When the next recommendation is when you're considering the purchase or the use of fluorescent lamp, you have to keep in mind that fluorescent tubes outperform compact fluorescent lamps. Both use more or less the same technology. Both of these are fluorescent tubes, but fluorescent, I'm sorry, when I say CFLs is basically a very small fluorescent tube. But one thing that you have to keep in mind is that fluorescent tubes last a lot longer than CFLs. They are also cheaper than CFLs, and then last but certainly not least, they are a lot more efficient than CFLs. So for example, if you have to light up a work area, let's say a kitchen, a corridor, an office building, instead of using CFLs, by all means you should replace CFLs with fluorescent tubes. I know that fluorescent tubes have a problem with aesthetics. However, there are some luminaires or some lighting fixtures that actually allow you to use fluorescent tubes in a very aesthetically pleasing way, also in public areas and in guest rooms. So if you have the chance to use fluorescent tubes, by all means do so. Fluorescent lamps are great. They're a lot more efficient than the traditional stuff, but one of the problems that we have with them is that they contain mercury, a very small amount of mercury. It's not going to kill you. However, if you ever break a lamp, you end up with a residue. You end up spilling this whitish powder that is contained inside the fluorescent lamp, and that whitish powder contains mercury. So it needs to be cleaned up appropriately. You can go and look on the internet for an appropriate way of cleaning up after a broken fluorescent lamp. The procedure is not that complicated. So if this happens only occasionally in your hotel, let's say you break one fluorescent lamp, every now and then it's not really a problem. But I've been in some hotels where they actually break fluorescent lamps on a daily basis, and that is really a problem. You should really handle these lamps carefully. You should dispose of them carefully, because yes, they do contain a toxic residue. Which leads us to the next recommendation, which is basically give preference to LEDs. LEDs, I know that up until a few years ago they were outrageously expensive. Now the prices of LEDs is coming down. These are really fantastic lamps. If you buy a good quality LED lamp, it's going to last almost forever. They are very sturdy. You can, they would take a little bit of shaking and banging without dying on you. And also they are incredibly energy efficient, and also they, from a aesthetic perspective, they look a lot more like your conventional halogen or incandescent lamps, and therefore you don't have a lot of aesthetic problems, or at least the type of aesthetic problems that you have with fluorescent tubes, or even with some CFLs. So whenever possible, if you're really planning to stay in business for a while, if you don't have problem with theft in your guest rooms or other hotel areas, then by all means go to LEDs. It's going to be a slightly greater investment up front, but your investment is going to go a long, long way. And the last recommendation that I have for you with respect to lighting is if you have areas with very, very low burn hours, let's say you have a closet somewhere in the back of your hotel where you only go in there occasionally and you end up turning the lights in those areas for let's say less than 30 minutes per day on average, then in those cases, yes, you can go ahead and leave incandescent lamps as long as you make sure you turn them off when you leave the area, because if you install a fancy LED, you're basically never going to recover your investment, because your LED lamp with those kinds of burn hours, it should in theory last for maybe more than a century. So if you have areas with very, very low burn hours, by all means just keep on using the traditional inefficient stuff. Next slide is has to do with lighting fixtures. It's great to have energy efficient lamps such as LED or CFLs or fluorescent tubes. However, it's a little bit silly if you have very efficient lamps and you put them in lighting fixtures or luminaires that trap most of the light that is produced by these lamps and therefore reduce the overall performance of your lighting application. You have some of these inefficient lighting fixtures which can actually absorb more than 3/4 of the light that is produced by the lamp. I've seen some examples where they were so inefficient that they probably trapped or absorbed more than 95% of the light produced by the lamp, and therefore it gives a very, very poor result in terms of energy efficiency. Here I want to give you a couple of examples of what I mean by inefficient lighting fixtures. And in figure number 1, you have a table lamp. The problem with this table lamp is that, first of all, it has a lampshade which is opaque, and therefore the light just doesn't go through the lampshade. This lampshade was made of metal. And what's worse is that the lampshade on the inside is painted black, so any color that strikes that black surface, and any light that strikes that black surface will get absorbed on the surface and won't even bounce back and make its way to the room. In figure number 2, you see another table lamp, which is obviously a much better alternative. The lampshade is translucent and also it's light colored, so whatever light strikes the lampshade, either it bounces down or up, or it goes through the lampshade and eventually makes its way into the room. In figure number 3, we see a recessed ceiling lamp, which you find in most hotels. As a matter of fact, in most places. And what you can see here is that the lamp is embedded in this hole in the ceiling. The hole is very narrow, and not only that, but there's no reflector behind it. Actually, this lighting fixture was designed for a spotlight type lamp, but in this case, in this hotel, they had replaced it by just a standard conventional incandescent lamp. By the way, the result would have been just the same, just as poor, if instead of having an incandescent lamp, they had replaced this with a compact fluorescent lamp. In figure number 4, we see a much better alternative for a recessed lamp. First of all, the opening of the lamp is much bigger, so the lamp, there is room for the light to escape this lighting fixture. And the lamp itself is surrounded by a reflector, a silver-coated reflector, and so the light that is projected towards the side can bounce off this shiny surface and make its way into the room. In figure number 5, we see a fairly standard garden light. This light has several problems. First of all, is that the slits through which the light can escape are actually very, very narrow. Those louvers that surround the lamp, they are black and they are opaque, and therefore probably my guess would be that in this kind of lamp, less than 20% of the light that is produced by the lamp actually manages to make its way out of the fixture. In figure number 6, we see a much better alternative, even though it's a slightly different type of garden lamp. Here we see that the lamp is coated with, is surrounded by a frosted glass plates, and therefore I mean, anyone can see that most of the light that would be produced by this lamp would be able to find its way into the garden. Next slide. Let me see if I can move this thing out of the way. Yeah, I think that this should be better. What is also quite important is to use light and reflective colors in spaces that normally rely on artificial lighting, such as a guest room, an indoor space, a bathroom, etc. You want to make sure that the walls, the ceilings, maybe the furnishings are of a lighter color rather than dark. It doesn't mean that everything needs to be white or silver plated, if that could be possible. Just try to avoid using too many dark colors. And the reason for this is that dark colored surfaces absorb an enormous amount of light. In figure 1, we see this instrument is called a lux meter. Basically, it measures the intensity of the light. So the little thing on the right is a sensor, and we see in picture number 1 that the sensor is facing outward, and therefore what we're doing here is that we're measuring the intensity of the light that is striking this white surface. And the intensity of the light, we can read it off on the meter. It's 7,600 lux. Now what we do in figure number 2 is we take this sensor and we turn it around, so now it faces the wall. It's not stuck to the wall, but what we're able to do now is we're able to measure the amount of light that is bouncing off this white surface, and we see that the sensor is able to read a light intensity of 5,300 lux. And therefore, in the case of this white light, 70% of all of the incident light, that is the light that struck the surface, is actually bouncing back off and keeps on traveling into the space, and therefore it can light other parts of the room. And that is pretty good, because that is what we want. What we see in figure number 3 is just basically the same experiment, but now we're doing this on a greenish type wall. In this example, in figure number 3, we can see that we have about 11,200 lux of light striking the wall. However, now when we turn the sensor around, we only get 1,600 lux bouncing off the wall. That means that in the case of this green wall, only 14% of the light is actually reflected off the surface. The rest of it gets absorbed. So you can see that if you had a room that was painted white, a lot of the light that went off the lamp and struck the wall would bounce back and illuminate other parts of the room, whereas if you had used this greenish color, most of the light would have just gotten stuck on the wall. It wouldn't have bounced anywhere, and the whole place would have looked a lot darker. What you can see in these two pictures is a pretty good example of what I was just talking about. On the left, we have a room that has dark wooden panels on the walls and also on the ceiling. And even though the curtains are white and the bedspreads are white, the whole room looks extremely dark. On the right-hand side, you can see another room where most of the colors are rather light. The walls are white, the bedspread is white, the floor is light colored. As I said before, this doesn't mean that everything needs to be white in the room. As you can see, one of the walls is actually light blue. This was a hotel in Cyprus in Greece, and therefore the light blue color kind of went along also with the location. But what you can see is that the room on the right is obviously a lot more pleasant. The problem with dark colored rooms or dark colored spaces is that no matter how much light you put in it and how much energy you actually expend in order to lighten up the place, it will always look and always feel like it's underlit. Another problem with dark rooms is that in order to try to make the place look a little bit brighter, you will actually need to install more lighting fixtures or install higher wattages lamps in the existing lighting fixtures, and therefore lighting up such a space will cost you a lot more money. Okay, moving on to the next slide. Take advantage of daylight. You know, daylight or sunlight is free. It's given to us by the sun. Thank you very much. And it's also excellent for us. I mean, us as human beings, we are designed to work with sunlight, and there have been countless studies which show that under daylight, when you work in or when you live in a place which is daylit, you are generally in a better mood, you work better, students learn faster, you are in better health, you are less depressed, etc., etc. So if we have daylight and the sun gives us a lot of daylight every single day, let's try to use it. However, in hot climates, you have to be careful about overheating indoor spaces. Sunlight carries light which is very bright, but it also carries a lot of heat. So if you have an enormous window that is fully exposed to solar radiation, this will be a very large source of heat into your space. And if you have to air condition that space, it's going to cost you a lot of money. Also, direct sunlight carries a very, very bright light, or is a very bright light. It has an intensity of about 100,000 lux, which is about 200 times more light than what is needed for most tasks. So, for example, on a desk, when you work, you're supposed to have about, I think, 500 lux, which is 200 times less light than what is provided directly by the sun. So this means that you don't need to have enormous windows in a space in order to be able to light up the space very effectively with daylight. What's more important is the location and the distribution of these windows. So I know that it's kind of a common practice in a lot of hotels to have wall-to-wall or ceiling-to-floor windows, but that is really not necessary in terms of daylighting. And also one of the things that you want to keep in mind is that the light that you want to try to get into your space is indirect solar radiations. By this I mean the light that bounces off the sky dome, that bounces off the trees and the buildings and the ground that surrounds your building or your window. What you want to try to do is to avoid having direct sunlight going into the room. So basically what you're trying to do is avoid what is shown here in figure number 1. I took this picture in a hotel in Portugal, and this was the shop of a hotel where I was working, and it had an enormous window which faced due west, and during the afternoon hours it got an enormous amount of direct sunlight, and therefore the poor lady that worked at the cash register, she actually had to deploy an umbrella in order to keep the sun from overpowering her. Another thing that you want to try to do is avoid what is shown here in figure number 2. This picture was actually taken in an office building in the UK, and that is why they can actually afford having the whole ceiling made out of glass. If you tried doing this in Singapore, where I live, you would cook. But this was a very good example of daylighting. They had a glass ceiling that was actually shaded by a mesh so that you only got diffuse light through the ceiling and not direct sunlight. But the problem with this picture is that even though they had all of the daylight you could possibly ever want to have, they actually left the lights on. If you see those 2 post lights in the front and also some of the lights in towards the back, you can see that all of the lights are on, which really is a very silly thing to do. I mean, you would be hard-pressed to produce more light than the sun, so basically you're just wasting your time and wasting your money by keeping lights on in a space that is properly daylit. Okay, moving on to the next slide. The next recommendation is basically try to use dimmers or dimmer switches sparingly, if at all. Dimming switches is personal choice or a personal taste, I think, because I go to some hotels where they have dimming switches everywhere, and you go into some other hotels and they have no dimming switches at all. The problem with dimming switches is that they require the use of special dimmable CFL lamps or LED lamps, and these dimmable lamps are harder to find, and they're also more expensive than your conventional lamps. So what happens very often in hotels that use these dimming switches is that they say, well, you know, let's forget buying the more expensive LED or CFL lamps, we'll just leave conventional halogen or incandescent lamps in these circuits, and then you end up with basically a room or a hotel that is just full very inefficient incandescent lamps. And what happens is that regardless what hoteliers think, is that many guests don't really use dimmable switches. I mean, it gives you the right mood, but in most cases, you know, when you're just going about your business in your room, you don't really need to dim the lights at 50%. You're just trying to put on your shoes or get dressed or do some work, and therefore just a regular on-off switch will do the job. The picture that is shown here is one hotel where I worked in not too long ago in Southeast Asia. They actually had, this is a picture that I took in my guest room, they actually had dimming switches even in the bathroom, which really is quite silly because, I mean, when I'm brushing my teeth, I don't really care about the mood of the lighting that surrounds me. Another problem with dimmable switches is that basically you're also spending a lot more money, and therefore you're really not doing yourself much of a favor. So use them sparingly and use them only where absolutely necessary, and save your money for better applications. The next recommendation is use a card key system or even a master switch to control lights in guest rooms. Card key system is basically those little slots that are located next to the guest room door, in which you're instructed to insert your key card in order to turn the lights on in the room. And the idea is that when you leave the room, you take your key card with you, and therefore after a short delay, all of the lights go off, and like that you don't waste energy by leaving lights on in an empty room. These switches are actually quite useful. They work very well. However, you have to be careful to use a switch that can't be easily tricked. And this is mainly a problem in hotels with very hot climates, or probably in hotels with very cold climates, where guests want their room to stay cool or warm while they're away, so like that when they return to the room is nice and cool or nice and toasty, depending on your climate. And therefore, if they know that they have to walk out of the room with their key, they are very often tempted to stick all kinds of things in the switch in order to keep it activated. And actually, that's what I show here on figure number 1. This is actually a picture that I took in my room. I was able to trick the switch just by putting in a little piece of cardboard. You do have smarter card key systems. Some of them use a little chip. Some of them use different geometry in the card that allows only the switch to turn on when only the right type of key is inserted. They will probably be a little bit more expensive, but they will certainly work a lot better. Also, when you have these systems, you have to be careful with internal sabotage by your front desk or even by your housekeeping staff. I've checked into a lot of hotels where the people at the front desk tell me, they give me 2 keys and they say, oh, this is a key that you can use to come in and out of the room, and this is a key that you just put it in the switch and you leave it there to make sure that all of the lights stay on. And obviously that is not the idea behind these switches. And what they're doing here is that they're basically sabotaging the system. The problem is that probably the front desk staff has gotten a lot of complaints of people who didn't quite know how to use these cards, and after a while they just decided it was easier to give the guests 2 cards. But that is really a pity. I think that in most cases, most guests know how to use these cards because nowadays you can find them all over the world. And also it just takes a little bit of explaining in order for the guest to understand how these things work. And also it's not because one guest complained that the hotel has to change all of its policy. I mean, that is not something that I have in any of my slides, but this is something that I wanted to talk about, and maybe this would be the right time to talk about this, is that the hotel kind of has to stand its ground. As they say in the US, is that the squeaky wheel gets the grease. It's basically you have a very few guests complain, and the hotel changes the way it operates just because of those very few complaints. And that is really a pity, because it means that maybe 99% of your guests have been using these keycard systems without any problems, but because 1% of your guests complain, you decide to sabotage the system. And to tell you the truth, maybe that one or two guests who complain about your key card system are the most expensive guests that you've ever had in the room, because they force you now to eliminate a very effective energy efficiency measure in all of your guest rooms. Now, in some cases, some hotels don't like these card key switches, or they don't want to spend the money to install them, even though I think that in most cases they're not that expensive. But if you don't want to install one of these key card systems, at least what you should do is install like some sort of a master switch next to the front door, so that the guest, as he leaves the room, can just flick that switch and turn off all of the lights, or almost all of the lights in the guest room. This is particularly important for rooms which are slightly larger and in which you have more lighting fixtures than normal. I was fairly recently in a hotel room. They gave me a suite, and I forget how many lamps there were in there, but there were at least 20, if not 30 lamps, and the switches were all over the place. And since I work in energy efficiency, I just can't leave my room with all of the lights on. And whenever I left, I had to leave my room, I really dreaded having to go around the room trying to figure out which light was controlled by which switch, and it would actually take me about 5 minutes to get out of the room. So if they had installed a master switch, it would have made my job a lot easier. And also, one of the things that you have to keep in mind is that most of your guests don't really care that much about how much energy you're wasting in your room. You know, they're there, they're paying you to provide them the service. If you make it hard for them to turn off the lights, they just won't turn them off at all, and that would be your fault, and you will pay for it. Okay, we're done with the lighting recommendations. And so now we will move on to air conditioning. One of the most important, or at least the first few recommendations that I would talk about, is what the things that you can do in order to reduce the heat gain into your buildings. And I'm sorry if anybody listening to this webinar is located in a cold climate. I mean, this I live in Singapore. The people who organize this webinar are located in Southeast Asia, where the weather is actually always very, very hot, and therefore most of these issues deal with air conditioning, or all of these issues deal with air conditioning. There are many things that can be done in cold climate, but unfortunately I just don't have the time to cover them here. Maybe we can keep them for another webinar. Okay, so what you want to do in a hot climate is that you want to keep direct solar radiation out of air-conditioned spaces. We had already talked about this when talking about lighting issues. But here in this slide, what I want to do is to show you what happens when you actually have direct solar radiation or direct sunlight streaming into a guest room through the windows. This is a test that I ran in a hotel in Portugal, in the building that is shown there in figure number 1. It was an L-shaped building, so some of the guest rooms faced towards the south, and therefore they were shaded by an overhang during the whole day. Then you had some guest rooms that were on the west, that were facing west, and therefore, even though they had this same overhang, in the afternoon, probably after 4 o'clock, a lot of the sunlight just streamed straight into the very large windows and glass doors that they had leading to the terrace. And you can see this in the picture number 2. This picture was probably taken at about 5 o'clock, and you can see 5 or 6 o'clock, and you can see that even though the terrace have an overhang, the sunlight is striking the glass doors, and most of the light is direct sunlight is going straight into the building. What you can see here in figure number 3 is basically the operation of the air conditioned in the shaded room from 5 p.m. until 9 p.m. And what you can see is that the AC goes on, and then it goes off for a while. It goes back, turns back on, runs for a while, turns off, and it cycles on and off like this continuously for the whole period of time. And when you look at the numbers, basically this AC unit ran for 60% of the time and was off for 40% of the time. Now we took the same measurements on the AC unit of the room that was actually exposed, basically the room on the west facing facade of the building, and that received direct sunlight throughout the whole afternoon. And this AC unit operated very differently. Basically, it just ran continuously from 5 o'clock until 5 p.m. until 9 p.m. and it only started shutting down, turning back on and off towards the end of the day when the sun was setting and the sunlight streaming in through the window was actually not that hot. So basically, the difference between the two rooms, two identical rooms in the same hotel with the same climate, with the same sun, the room that is exposed consumes 40% less energy than the room. The room that is shaded consumes 40% less energy in order to stay cool than the room that is exposed to direct sunlight. So keep this in mind. This is probably one of the most important things you can do in hot climates. What are the options that are available to hotels in order to control direct solar radiation? Well, the best option is to actually shade the glazed surfaces or the windows. So by glazed surface, I mean windows or glass doors. Shading, a simple shading, whether it's done by a tree or by an overhang, it can cut the solar heat gain into the room by more than 80%. So basically, your trees or your overhang are really having a significant impact on reducing the energy consumption of your AC unit. What is important to keep in mind, though, is that the shading should be done on the outside. What you want to do is you want to stop the solar radiation before it touches the glass, and therefore you want the shading element to be outside of your building or outside of your guest room, not inside. Once the sun goes or the sunlight goes through the glass, it's already too late to stop it. So it's important to stop it outside. So some of the options are as follows. What you can see in figure number 1, you have an overhang. Basically, it's a very simple and very old technology, but incredibly effective because it can really shade your glazed surfaces very well. The one thing to keep in mind is that overhangs don't work very well on east-facing and west-facing facades, because on the east-facing facades the sun is very low in the horizon during the morning, and so the sun will get under your overhang and will still be able to strike your glazed surfaces. And the same thing happens on a west-facing facade, but instead of in the morning, in the afternoon. In the afternoon, the sun is also very low in the horizon as it gets ready to set, and therefore the direct solar radiation will go under your overhang and will still strike your glazed surfaces. However, overhangs are extremely effective on south-facing facades if your hotel is located in the northern hemisphere, or north-facing facades if your hotel is located in the southern hemisphere. Another option is to have a movable shading device, and this is shown here in picture number 2. This picture was taken in Singapore, where I live. This is an old colonial home that was built before air conditioning existed, and therefore they had to find clever ways of keeping the heat outside of the building. And what you can see, it's pointed out by an arrow, what they would do is that they would hang these bamboo blinds that they could roll up or roll down depending on the conditions. If the sun was striking the window and a lot of heat was coming into the room, they would just roll these bamboo blinds down, and therefore you would still be able to get a little bit of sunlight, because the sunlight would strike the bamboo mat and a little bit of it would get through it into the space, but most of the heat would remain stuck on the bamboo mat and never make it into the room. So this is actually very, very, very effective. Now you don't necessarily have to use bamboo mats. You have some of these screens that are made from synthetic fabrics that are actually engineered to give you just the right amount of light going through, or the right amount of shading. It's a very simple solution, very effective solution. This will work on any orientation. If you can install these blinds or these shading devices on east, west, north, south facing windows, it just doesn't matter, they all work. Figure number 3 shows you some louvers that are installed on top of a skylight. Skylights are great, but in a warm climate they will let in a lot of direct solar radiation during much of the day. So what you want to do is you want to install some sort of a mechanism that will break this direct solar radiation and allow some of the light to bounce off, for example, the wooden lats of this louver, but keep the direct solar, but stop the direct solar radiation from going through the glass. You can also use vegetation. Vegetation is incredibly effective at providing good shade. This is a good example shown here on picture 4. It's kind of a terrace in a Greek hotel, and you had this vine that provided a lovely shade. Vegetation is cheap and it's fantastically effective. Now, if you can't install any of these shading devices for one reason or another, then what you can do is apply some sort of solar control film on your glazing, which are also engineered to give you the right amount of protection. Moving on to the next slide. Another thing that you can do in order to keep in order to reduce the heat gain into your air-conditioned building is to insulate and ventilate roof cavities above that are located above air-conditioned spaces. The roofs of a building are exposed to direct solar radiation during much of the day. They become very, very hot, and if your roof cavity is not insulated or ideally ventilated as well as being insulated, a lot of this heat will make its way through the ceiling of the room that is below the roof and into the air-conditioned space, and then you will have to spend a lot of money in order to pump this heat out of the room with your air-conditioning units. What these diagrams or what this picture shows is a test that I ran in a hotel located in a tropical climate. What I did is that I installed a sensor, a temperature sensor, on the inside, the lower surface of the roof, and then I installed a sensor on stuck to the top of the ceiling in the guest room. And what I did is that I tracked the temperature of the roof and the ceiling and the guest room ceiling over 2 days, and that is why this pattern of up and down is repeated twice in the diagram, which is shown here on this slide. The time scale on the slide goes from midnight to the 24 hours of the first day, then you have midnight again in the middle of the graph, and then you have another 24 hours going after that. The temperature of the roof is represented by the red dotted line. The temperature on the inside of the guest room ceiling is represented by the green line. And what we can see, for example, on the first day is that in the early afternoon, probably at around 1 or 2 p.m., the temperature of the roof rose to about 52 degrees, and the temperature the inside temperature of the ceiling in the guest room rose to 40 degrees. This is an incredibly high temperature, especially considering the fact that normally if you have an air-conditioned space, you're trying to keep the temperature in that space at about 23 to 25 degrees C. So here we're talking about a temperature of a very large surface, which is 15 to maybe 18 degrees higher than the temperature you're trying to keep in the room. If you apply ventilation in this roof cavity and you ventilate it and possibly even add a radiant barrier, you can actually reduce the heat load going into your guest room through this roof cavity by more than 85%, and therefore the energy savings are quite significant. In this slide, what I would like to do is to show you what is the impact of these good practices on the temperature inside a building. So what I did here is I measured the air temperature, that is the temperature of the air in the middle of a guest room, and this was in a hotel in which they had some rooms that were very well protected, that is the roof cavity was insulated, they had a good overhang, and during the course of the whole day there was no direct sunlight striking the windows. And they also had some rooms that weren't so well designed. They got a lot of sunlight through the glass glass doors and windows of the room, and also they had a roof cavity that wasn't insulated. And I tracked the temperature, the air temperature in these two rooms over a period of, again, 2 days, just to prove that the pattern was repetitive. So as you can probably guess, the temperature in the exposed room is represented by the red line, and the temperature in the protected room is represented by the blue line. And what you can see is that, again, in the early afternoon, the temperature in the exposed room climbs to more than 35 degrees centigrade, while the temperature in the protected room stays below 28 degrees. The difference between the two is enormous. 7 degrees centigrade makes a really big difference. And therefore, obviously, if you had to air condition these rooms, it would cost you a lot less to air condition the protected room as compared to the exposed room. Another thing that you have to do, or that you have to keep in mind, in order, if what you're trying to do is reduce the heat load going into your air-conditioned spaces, is that you have to try to use reflective colors on walls and roofs. And this would be the walls and roofs that are exposed to direct solar radiation. As we had mentioned before, dark colors absorb the light. And in the case of sunlight, it absorbs the light and it absorbs a lot of the heat. So depending on the color of your wall that is exposed to the sun, that wall will could remain reasonably cool, or could actually get quite hot. This is a picture that I took in a hotel somewhere in the tropics. I forget where it was. But basically it's the same wall. What I'm doing there, I'm just measuring the temperature of the wall in the white part, and then on the right-hand side, I'm measuring the temperature of the wall on the part of the wall that was painted blue, and you can see that there is an enormous difference between the two. It's basically the same wall that was exposed for the exact same amount of time to the same amount of sunlight, but just that the white wall was able to reflect a lot of the incident light, and therefore it remained about 13 degrees cooler. And one of the things that you have to keep in mind is that a lot of the heat that I'm measuring there on the outside surface of the wall with my thermometer actually goes straight through the wall into your air-conditioned space. And therefore, if you had a guest room that was whose outside was painted in blue, it would cost you a lot more money to keep it cool during the daytime than the same guest room if it had been painted white. Now, the next few slides, I want to talk about what are the things that you can do to the way in which you maintain or operate your AC system in order to reduce the energy consumption of this AC system. One of the things that you have to do is basically keep the best thing you can do is to keep the temperature at a reasonable rate, at a reasonable level, which is typically about 24 to 25 degrees C. What I've done here on the graph on the right is that I tracked the energy consumption of the AC unit over a period of 2 days in a restaurant that I think it was an 80-seat restaurant in a hotel that was located in a hot climate. And what we can see is that when the thermostat is set at 21 degrees C, the AC unit basically never stops working and consumes on average 18.3 kilowatts. When we lowered after the first day, when we raised the temperature setting in the AC unit to 24 degrees C, the energy consumption of the AC unit dropped down to 10.2. The result is that the energy savings, the energy consumption of the AC unit was reduced by 44%, and just in the operation of the AC unit of this hotel, we were able to save about $6,000 per year. Some of the other things, I realized that actually I've spoken a lot longer than I should, so I'm going to try to go a little bit quicker. Some of the other measures that you can do in order to keep the energy consumption of AC systems down is, first of all, take advantage of natural ventilation. You can see this in in figures 1 and 2. Figure 2 is a hotel located on Nicoy Island in Indonesia, where even the guest rooms were not air conditioned, and it was a wonderful place. Use ceiling fans. A ceiling fan will allow you to feel a lot cooler, even though the temperature is still relatively high. In pictures 4 and 5, the idea behind this is try to keep the windows and the doors closed, because you want to keep the air-conditioned air inside your air-conditioned space, and you don't want it to seep outside. Picture 4 shows a restaurant in a hotel where, for some strange reason, at lunchtime they actually serve the food inside the air-conditioned spaces, but with all of the doors open. In picture number 5, this is a hotel in Mexico where they did have an automatic opening and closing system on the lobby door, but you had a lot of bell buttons that always hung out right in front of the door, which activated the sensor, and therefore the door was left open for most of the time. In picture number 6 shows a keycard system. You can use a keycard system obviously to also control your AC unit. Picture number 7 shows a window or a door switch, which basically turns off your AC system automatically if the windows are left open for a long period of time. And picture number 8 shows a cover for a thermostat, and the idea behind this is that you want to avoid having, especially staff, tampering with the settings of the AC system. So you have a cover that is locked, and only your maintenance staff can have access to the AC system. So if you set a thermostat at 25 degrees, it will stay at 25 degrees because nobody will be able to change that AC setting. Some other recommendations. Number 1, make sure that your insulation on your refrigerant pipes is in good condition. Picture number 2, make sure that the insulation is protected from direct sunlight, because the sunlight will eat through your insulation. Picture number 3, make sure that you periodically clean the air filters on your evaporators. Here you see an air filter where all of it was dirty. I just cleaned one of the corners to show you what it should look like when it was clean. In pictures number 4, 5, and 6, the idea here is make sure that your condenser can actually breathe. You don't want to have anything around it that will obstruct the airflow through it, because if you can't get a good airflow through your condenser, your AC system just won't work effectively. Now, hot water. This is the last slide. The idea here is to use hot water efficiently. I mean, I know that there was a webinar a couple of weeks ago in which they talked about what are the things you could do to reduce hot water consumption. Here I just want to talk about the energy implications of this. Heating water takes an enormous amount of energy. The water that is used for a 10-minute shower in an efficient shower head, it requires about 2 kilowatt hours of energy, which is basically the energy that you need to run an AC unit for 4 hours or a typical guest room light for 130 hours. So a 10-minute shower can really blow a lot of energy. So you want to make sure that your fixtures that use hot water are actually effective. So a shower head should ideally consume about 8 liters per minute. A bathroom faucet or tap should consume about 5, and a tap in a work area such as a kitchen or laundry should consume about 8 liters per minute. And at least based on my experience, making efficient use of hot water is one of the best measures you can apply in a hotel in order to significantly reduce its energy consumption. Okay, I'm done with all of my slides. I don't know if the problem was fixed or not, so I would just like to thank you for sitting through this long presentation. I hope it was useful. If you have any questions, you can contact me. For me, the ideal way for you to to get in touch with you, or for you to get in touch with me, is through LinkedIn. My LinkedIn ID will be posted, I think, on the copies of these slides, which will be left on BookGreen's webpage. So thank you very much, and I hope you have a great day.
Thank you, Patrick. Very good information. If anybody have the question for Patrick, could you please type in your question, and then I will read it to Patrick, and then we try to answer you as much as I can. Okay. I have also some announcement that because our moderator and Anthony could not join the webinar because of a technical problem. Also, some attendees also cannot join the webinar. We are very sorry about this technical problem, and we will try to reschedule the second part of this webinar for next week. Okay? Sorry about that. If you have any question, please feel free to type in the question. Patrick, we have one question. Let me try to read it for you. The question is, do significant variation in voltage from the electricity supply impact upon LED lamp life?
Okay. Can you hear me?
You want me to answer, read you the question again?
No, it's okay. I understood the question. Well, if you have significant variations in voltage, it will affect LED lights up to a point. I think that CFLs are actually affected more greatly with variations in voltage than LED lights. But yeah, I mean, I think that this could be an issue that would prevent many hotels from using LED lights. However, I have worked in a lot of hotels all over the world, and in most cases the quality of the power in the hotels is good enough to allow you to use this type of technology.
Okay, we have another question. Do you have any recommendation on the color area and energy for heating?
Can you repeat the question, please?
Sorry, any recommendation on colder areas and energy for heating?
For heating space?
Yes.
Well, yes, I mean, I think that this should actually be the topic of another webinar, because yes, of course, there are an enormous amount of recommendations for heating spaces located in colder climates. I think that instead of focusing on the heating, I would rather focus on the efficiency. I think that producing the heat that you need to heat the space is one thing, but also what you want to do is you want to make sure that whatever heat you pump into the space stays there. So you have to make sure that your windows are properly insulated, so using at least double pane windows, that your walls are well insulated, that that the roof is well insulated, that you reduce air leakage in and out of the space, that you have insulating curtains that actually you can pull down and keep a lot of the heat from leaving the heated space through the glass during the night. Yes, there are many things that can be done in order to make sure that the heat that you put into a room stays into the room. In terms of technology that can be used for heating, you have many options. Probably some of the more efficient options are heat pumps, which is basically an air conditioner in reverse, and therefore for 1 kilowatt of energy that is consumed by the heat pump, it's able to actually produce, I believe it's about 2.5 to 3 kilowatt hours of heat into the space that you're trying to heat. So obviously this is a very good solution. You can also look at different sources of energy depending on where you're located. If you're located in a place where there's a lot of wood waste or a lot of agricultural waste, burning that as a source of energy is relatively cheap, and it's actually environmentally friendly, because you're burning a crop that will be planted the following year, and therefore your carbon footprint stays very low.
Thank you.
However, one of the things that I would like to mention is that this is a really very, very broad topic, and you could actually have a presentation just on that that would last for more than an hour. So maybe we should use this as a topic for a next webinar.
Okay. We have another hard question. The question is, what do you do to encourage guests to save energy? I think this question is very good for the second part that Kun Anthony will talk about the practice that he did on his hotel. But I think maybe Patrick maybe have some answer for this too.
Yeah. I mean, obviously, what you want to do is you want to make sure that your guest doesn't use a lot more energy than absolutely necessary. However, one of the things that you have to keep in mind is that your guests, especially if you're talking about, well, I think that any guests, they're coming to your hotel to be able to rest, to be able to have a fun time, to be able to relax, and so they're not coming to your hotel to save energy. So for me, I think that instead of putting the burden on the guest, I would much rather put the burden on the hotel. What you have to do is that you have to provide your guest with a room that is designed well enough so that the guest can go through his or her business without wasting a lot of energy. So that is, give them a shower which is a good quality, that provides a good quality stream, but that only consumes 8 liters per minute. Give them a bathroom tap that will only consume 4 or 5 liters per minute. Give them lamps that are energy efficient. Make sure that you install a master switch by the front door, or that you have that you use a key card system, so that when the guest leaves the room, he could just press a button and turn everything off. Very often, hoteliers blame the guests for the high amount of water and energy that the hotel consumes, and based on my experience, generally the guests are not to blame. Yes, you do have some guests who leave the AC on with the doors open and the windows open, and yes, you have some guests that are incredibly wasteful, but I think that overall guests are just normal people. They are there to have a good time, and therefore if you give them technology that will help them live in your hotel efficiently, they'll be more than glad to use it. I think that the one place where your guests can have an input on your energy consumption, as a matter of fact, your energy, water, and chemicals consumption, is putting in place a good towel reuse program, a good bed linen reuse program that allows the guests to use their towels and their bed linens for more than one day. But there again, the onus is on the hotel to make sure that the systems that they put in place work well. I'm sure that, well, I have, and I'm sure that everybody in this webinar has been to hotels where they have a towel reuse program, where they beg the guests, please help us save the world, please help us save the whales, etc. Hang your towels up, and then you hang your towel up, you come back the next, you come back on the evening, and the housekeeper has changed all of the towels. So the problem here is not that the guests don't want to participate, is that the hotel isn't doing what it should be doing. The problem with these programs is that management puts them in place, but very often they don't follow through, and therefore they assume that just because they have a little card that says, we have a towel reuse program or a bed linen reuse program, that the program works, whereas in most cases it doesn't work because the staff hasn't been trained properly, or the staff hasn't been given the proper support in order to make sure that the program works well.
It's a time of for our audience to start implementing these energy efficiency policies in their hotel, and I really look forward to their stories. Okay, let me tell you a little bit what's happening next. We will have a webinar in beginning of August. We'll send you an email about it. It's how to make a positive impact on the local communities. So if you want to join, just send us an email, and later on you will receive a link so you can participate. Yes, I think that's about it for tonight. And we look forward to having everybody joining us for our next webinar next month. I wish you a great evening here in Bali, and good day to you if you're in America or in Latin America and you got up very early to be with us. All right, that's it for it today. Bye-bye, everyone.